I have two questions. I'll ask one first. Why did you use holism to oppose reductionism rather than emergence or emergent properties?
Oh, because I mostly was going by Ernst Mayer's kind of things, so I used him as a kind of a model of that. The emergent property thing, I think that to understand emergent properties, which is what people usually take as a kind of thing as opposing to reductionism, I don't see that as opposing at all, because to understand how things can emerge, they have to emerge from something. So you have to understand what the parts are before you can see what emerges from them.
But then you could stress what emerges as more significant than the parts.
Well, what makes it more significant? I don't know. I mean, it depends what you want to know. I mean, the idea of emergence is that you get properties that you would not have predicted from just looking at the parts by themselves. But they still come from the interaction of the parts. You know what I mean? So if you understand all the interactions, you should be able to understand how some of these things emerge. So if you want to know why a water molecule has the properties that it has, which when you look at hydrogen and oxygen is not obvious, you can still find out by doing, understanding how they come together, what forces act between them. It's a complicated problem, but
in order to talk about organic phenomena, you have to talk about the parts.
Yes. In order to understand how a cell works, I think it would be incomplete if you just make a catalog of descriptions of how a cell works. That would certainly be part of the explanation. But would that really be a complete explanation if you don't understand how the different parts work and what the parts are and why they have the structure that they have? And, I mean, my point is to understand all of those different parts, you have to have both. Otherwise, you don't have a complete explanation. David?
Your idea of reduction seemed to be something like a kind of relation of deducibility, or which you can understand one thing in terms of another by something about the parts, say, entailing this,
and the interactions,
and the interactions too. And you seem to say, well, the model looked like, well, there are these steps. You get from Schrödinger's equation to orbitals in a hydrogen atom, and then then hydrogen and oxygen atoms together, water and proteins and the like. If this relation is one of deducibility, though, the steps could be eliminated in principle. It seems like, I was just unclear what the status. So if A entails B and B entails C, then A entails C. So you seem to say, yes, life can be explained physically because you explain
some parts of it,
in this stepwise fashion. But somehow the steps are necessary, and that makes it. That's something that the bad reductionists seem to fail to see. That you need the intermediate entities along the way, and so that was your way of denying what the bad reductionists said. And I was just wondering if there are in fact these relations of entailment from Schrödinger equation to orbitals in a hydrogen atom to water. The steps would look like it depends on us. Well, it's still hard for us to go directly from Schrödinger's equation to a protein.
You're getting it.
So it looks kind of subjective. If we were smarter, we could see that. And the kind of the indispensability of these intermediate levels look like, well, we're just not smart enough to see them. I mean, we're not smart enough to see this link directly. And I was wondering what the significance of that is.
Okay, that's a really good question. So, for your point, for example, it's like say I have a protein that has a certain function, it does in a certain way. If I would have a really giant computer, I could just plug in Schrödinger equation and it would give me everything about this protein.
Yes. The things you
But
explicitly
they were just not smart
said,
enough. You can't build a good enough computer.
the things you explicitly said that physics couldn't explain were accidents and like historical accidents, like the way DNA molecules just use proteins, or just use amino acids. So why not others? That was the thing you said that physics explicitly couldn't explain, but that's kind of like, well, that's one of your data that the galaxies are distributed this way, or these particular molecules are used. That's not explained by anything anyway.
I think it comes down to a little bit what Leon asked about the emergence thing. So if we had a big enough computer that could solve a protein structure, we would get the structure of the protein.
Yeah.
And we would get probably the structure of a protein under various situations. We could even calculate how this protein interacts with other proteins. However, if you wanted to get to what the function of that protein is, that function of the protein only has any sense if it's in the context of a cell. So in principle, you could, if you had this really super duper giant computer, you could take every protein in the cell and let them and simulate all of them and let them all run around it. You would simulate the whole cell, and I would say that would be in principle possible, but when you would look at the simulations, and we don't really need the simulation because we've got the actual cell there, so why do we need the simulation, right? You would still could really not put in words, how this function and why this enzyme does this here and why this comes there, in terms of atoms or elementary particles or something. You know what I mean? It's like the language would be inappropriate to describe it. So yeah, in some sense, it's a limitation of the human mind. I mean, I would say that. I would say it's a limitation of the human mind to think all the way through this stupendous complexity of things. But in principle, I don't see there's any additional component in a cell that is not part of physical laws. I mean, I would say that, yeah. But it would be very impractical to try to explain all the stuff in the cell by solving Schrödinger equation, which is crazy.
You've got chance and necessity. I'm not quite. Necessity seems to be like the laws.
Laws of nature.
Laws of nature, and then chance in the environment, how they work out. Where would potential fit in? I think that just, you have the Big Bang and you have the formation of the hydrogen atoms and stuff. It seems there's potential there in the randomness with the laws and the chance. I think that's what really flabbergasts us, is that when we produce things, that there's so much potential for emergence in that simplistic thing. What is potential? I mean, how could you? I mean, you said you could, if you have the water, you could look and see what its potentialities does, and physics seems to be able to do that in a limited range. But can we predict consciousness, or can we predict something else besides consciousness? Or there's certainly potentials there that emerge, and we don't know what they are until they emerge. Really, we can't predict consciousness until it emerges, and then we see that it's the potential. So it's hard to predict. There are some potentials, but we don't know what they are until they emerge.
Yeah, I think that's the biggest question, and I think what maybe science has done, some reductionist science has done, is it eliminated certain possibilities for that to explain this from the equation. Meaning like people, like in the 19th century, people are looking at embryology and they're saying like, oh, this is a cell and it starts dividing and dividing and dividing, and suddenly it turns into this, thing like a frog or something. So there's this potential in this cell, right? But we have a pretty good understanding that it's not. They thought that there's a vital force or some kind of mysterious, mystical thing, but that's not really there. So we have eliminated explanations, but can we really say in one sentence